Hello, math aficionados. This is Victoria, and this is my introduction to Chapter 6, and we're going to be talking specifically in this video about Section 6.1. We're going to keep it basic and just define what a rational function is, and then to show you how to determine their domain and to write their domain in set builder notation and interval notation. So let's get started. A rational function is a polynomial with a quotient. So what does that mean? That means that it has a numerator and it has a denominator. And here's my example right here. So to be rational, it has to have those two parts. It has to have the fraction bar. So it's a quotient. And the second thing we talk about is its domain and where it is and isn't defined. One key concept to all of mathematics is you cannot divide by zero. So we're going to define the domain by telling you where it can't exist. Okay, because we're going to say that we're going to replace x with all the real numbers, and the question is there any place where a real number will cause that denominator to be a zero? Because if it does, then we have to throw those values out. So let's look at my example right here. Okay, so I've got y. I could have wrote this as f of x. So y is equal to x minus 2 over the product x minus 1 and x plus 1. So we're going to concern ourselves with this denominator. And we're going to worry about where it may be a zero, where it could end up being a zero. Let's see if I can get my tools here. There we go. Okay, so the way that we do that is we take each one of these parts, or sometimes there's just one factor, and we're going to set it equal to 0. So let's let x minus 1 equal 0, and let's let x plus 1 equals 0. Now these are pretty easy equations to solve, right? We're going to get add 1 to both sides, we'll get x equals 1, and on this one we add -1 to both sides, we'll get x equals -1. So these are the places where we're going to have to exclude them from our domain. We're going to have to exclude them because think about it. If we plug those values into our rational equation, we get 0, and we can never divide by 0. So how do we show that? Well, we've got two different ways to show it. We've got what's called set builder notation, and we've got what's called interval notation, and they're kind of different. So in set builder, we're going to have a description, and it's going to look something like this. We're going to say we have the set of all values where x, values of x, such that x is not equal to 1 and -1. There you go. So I've got these scrolly brackets. And again, you're going to read this mathematically. It says x, it's the set of all x. What's inside here is the set of all x such that, that's what that bar means, x is not equal to 1, comma, -1. So those are values that we're going to exclude. Now let's go ahead and write it in interval notation. It's in our interval notation. Okay, and so we're going to start. Where do the values for x start, the domain? Well, they're going to start from -infinity. And they're going to go all the way up to -1. They're not going to include -1. And the way I'm going to notate that is I'm going to do a curved bracket. If I did a square bracket, then it includes that number. And that's not everything, though. That's going to be intersected with, or union with, I'm going to start at -1, and I'm going to go all the way to 1. And then I'm going to start at 1 and go all the way to positive infinity. And I'm going to just kind of show what I'm saying here. So if this is my number line, and the domain is all the values where x is valid, there are places where I can't have, where it doesn't exist. Let's say this is 0, and let's say this is -1, and let's say this is +1. So there's going to be a hole in my values. Okay, there's going to be a hole. It's not going to exist here. There's going to be a hole right here, and there's going to be a hole right here. But all the other values here are valid. Let's see if we can put this in another color here. So my domain is going to be start here at -infinity, go all the way up to, and it almost going to cover, get to -1, then it's going to be all the values between 1 and +1, and then it's going to go up to positive infinity. With these two spots here are holes in my values, because that's where it will be equal to 0. So what I'm trying to show you here are two different ways of writing this problem. So again, going back up, we had this rational function. It's rational because it has a numerator and denominator. And because of that denominator, we have to be very careful about the domain. We can't have 0 in the domain. And so we set the terms equal to 0, we solve for those values, and then we can describe our domain in two different ways. We could describe it as in set builder notation, or we could define it as interval notation. Either way. Now in my math lab, it may request it in one, the other, or both. I hope this video has been helpful to you, and I will prepare another video on each of the other two topics that we have from this chapter. Have a great week.